Hi everyone, welcome back to yet another episode of our podcast series Future Ready Systems with Krishna Kumar. And today, as always, we have Mr. Krishna Kumar, AI architect and modernization specialist with us to guide us through the session. Welcome, sir.
Thank you. That's awesome. Having another session with our friends.
Yeah, of course. So, in the last episode, we talked about databases and how important it is to choose the right one. So, even if you choose the right database, many companies face a big problem, which is the communication between their systems. So, today we are going to simplify this a term everyone knows, but only very few understands it truly.
Yes.
APIs. It's the how your systems talk to each other. So, sir, what does the term API simply means in a plain words?
API is nothing but something like picking up the telephone and talking to somebody in the other room or in the other apartment within your own complex. The communication that happens up and down through both of these different entities is what it is API. It's a methodology or a communication channel, different channel. We have telephones, we have intercoms, we have mobile applications, we use online VoIP calling. Same way, API is something where machines talk to database and database responds back to them in the language they understand.
Okay.
So it's just a communication methodology, that's all.
Okay. So, if API is a bridge between the systems, why do many modern systems rely on that so much?
See, now what happens is companies have been implementing automations over a period of 20 years, 30 years now. So when they started small, when the technology what was available, they started implementing with that. As they grow, as newer people come into a system who are experienced on new systems, they start implementing it. But the old systems is always available there. And never an overall happens that where you ditch all your old systems and get into a new one. That happens once in maybe 2 decades, a decade in a company if the growth is fast. Those are the timelines which happens. But in between this 8 years or 10 years period, there are multiple new improvements, multiple add-ons, multiple upgrades that happen as per the requirement of companies because the companies are growing. With the growth and scaling in mind and the real happening on ground, you need upgradations. And with those upgradations, you need someone who can talk between the older systems and the newer systems to an extent. And more than systems, what it is when you build a new application, it may rely on multiple systems to get you the data. For example, you are building up a new MIS for the management, a small thing, not a very big thing. But if the MIS needs to get data, it needs to get from the finance department, it needs to get from the marketing, it needs to get from the operations bay, it needs to get from the manufacturing bay, it needs from the inventory, the store guys. Everybody, all those information need to be combined and then brought in a format that could be understood by the management. For something that needs to go to all these places, pick up the data and then combine everything is what is an API. It is different channels of asking a question to a different data set and getting the real answer that is needed. Now, if this is not optimized, you are boomed.
Okay. So, as we say, communication is the key. It is the same for the systems.
Exactly.
Also.
Communication is always the key. Now, the way you talk, if you give me a whole story and then you start telling me the answer, I am going to spend that much time answering to you. And that answer, when you get back, the time spent in your question, in my answer, and the travel time between these two is what's going to affect the guy who is going to see this. Even the podcast, the guy who is going to say this, what is going to affect is how much time he needs or the system takes for him to get an answer that he's asking for. So the faster the answers is given, the very small and comprised answer that's given is what they need. They don't need a story, they need numbers. Everywhere the world runs on numbers. If someone needs a story, it's for a learning purpose or it's for when you have nothing to do. No, that depends.
Yeah. Okay, that makes sense. So, if everything depends on API, what happens when they are no when they are designed poorly?
That's the bigger question.
Yeah.
Anything designed poorly always has problems. Even in a house, even the environment or the interiors that we design, if it's not designed keeping into mind the aesthetics at one part and the usability and the maintenance, these three things are not combined and planned on, it's havoc in a year or two. Same way with APIs, if the data is low, it plays around because you are higher infrastructure. But as it grows, the same way at home it happens, maintenance on the infrastructure, maintenance and reusability of those becomes tiring. The same way with APIs, if it's not designed properly in a way that it can run faster and the outputs can be faster, not in a sense that you see on the front end by the user, but in a sense it's calculated from the back end, the time lag that happens for a particular set of data from a particular big bucket, maybe a smaller bucket now, but if that grows, what kind of times it may, if you don't analyze that, you are going into a scenario where it becomes dust or maybe a dust storm when you ask for something. A lot of data flying around the world, and this guy API has to go and start fishing up and getting the right data. So this is where most companies get stuck at places. If I give you a lean example, there are 5 databases that you have in your organization for 5 different things. Basically, the inventory part of the store is handling something, a different application, a data set for their vendor process, for the stocks coming in and the deliverable stocks or the stocks going into the operations. They use a different application. The manufacturing bay uses a different application to track the flow of the components and the manufacturing process that happens. The finance guys has a different system that runs, and the sales guys, they use any CRM one for that. They use something else for building the proposals. Now with this 5, if you want to have a combined data of one customer, his products, his payments, his deliverables, you need to go to all the places with the interconnectivity for the same customer, get the same data which is clean, and then present it to you that this customer has been working with us for these many years. These are total products that has been delivered. The expense of each delivery was that. The expense of the purchase for each of these was that. And this is the profit ratio that we got of that. And this was closed by X salesperson.
Yeah.
Now to get that, if the APIs go and, for example, it goes to the finance guy, ask it for all the sales that happens in the last 2 years, you have a very big jump up.
Yes.
Whereas you don't need that. You just need the sales that was done by X salesperson, and that's being used by the X customer, and that relates to the money that has come from this customer. So you get a very less set of data that is formatted for you. Then when you connect it with the finance, with the manufacturing or the inventory, you get it connected, you exactly get a few line items that can be merged and used.
Okay.
And same way in a year, you do, if there are 100 transactions, you don't need 100 transactions. You want a combination or a sum of those. That can be captured, how easy it is, how fast the results will be. This is what optimization of API in a very base level is.
Okay.
If that is not done by the architects who design the application, then the application will run in a testing mode because there is very low set of data and your data is implemented or created the way you want the answers.
Yeah.
But in real time, it's not that.
Yeah.
Everybody from the world starts creating data. So unless that is pretty validated there, pretty strictly controlled there, and the clean data goes in, then you get the APIs giving you good results.
Okay.
You won't know in the beginning stages because you have always across 95% of organizations to 98% of organizations, you have the infrastructure always over-engineered, looking at next 5 years or maybe 7 years. minimum 3 years they have over-engineered that. So today it will run full speed. But after 3 years is where you get really the problem starting coming in, and finding out what the problem is another problem. Where you spend more amount of time and money into that.
Yeah. One problem will lead to another one.
You don't know which is the problem. That finding the real problem is the problem.
Okay, so
As I have been talking some time back in one of my old podcasts, for any problem you should ask why 5 times. So those 5 whys will give you the real problem and not the superficial level of problem. That if solved, the real problem is solved, you are solving this major problem for a longer time. Else we are always fighting on the superficial levels. It's like the jungle fire. If you start just beating the bush and stopping the fire there, the problem is not there. The question is why that fire happened and how it spread. If you try to solve that, this fire won't happen next time. Else you're always doing firefighting.
yeah, that's a simple
Most
explanation.
company CTOs and tech leaders are day in and day out firefighting.
Okay.
This is the reason for that.
So even if individual systems are fast, poor communication can slow down things, right?
Absolutely, there is no doubt about that.
Yeah.
It will slow down, it will always slow down your whole system.
Okay. So, sir, can you walk us through what happens behind the scenes when a user clicks something?
Oh, that's a good question. Yeah, for the layman level, not for the senior tech engineers who have been into the software development process, but the engineers who have been into manufacturing, who are into R&D kind of roles, they have a bit lower view into what happens inside, but at an overall view they have a good idea of what happens on the top level from the eagle eyes point of view. For them it's basically what happens, a front end request comes to you and the back end receives that. That request is clicked, when the click happens, the front end generates the result and sends it to the back end. When it goes to the back end, then the back end is what calls the API related to that click. When it calls the API is sent as a query to the database. It goes to a database, filters out the data as per the database API queries, and then picks up that and then brings it through the back end to the front end and displays it to you. So this is the whole process it goes, and the same way it comes back to you. Now the lesser amount of time, because from front end to back end is pretty fast, just milliseconds, hardly milliseconds. And from back end to the API, that's also fast, because it's already set and coded for you.
Yeah.
Then from the APIs to the data set, is going becomes fast, but the retrieval becomes slow, because this depends on how much of volume of data you asked, what all filtrations you are asking it to do in the database before picking up what it needs. Like if you open a cash box, you have different denominations, different coins, maybe 15 different, 20 kinds of different things. Now what to pick up from where, this guy has to search around things. If it is not properly set, if you have a cash box properly laid out, thousands, hundreds, 500s, in line, if you know, this guy knows if it is ones, I just go to this point. Else it goes to 1, 2, checking where it's a 1, where it's a 1, then it goes to reaches 1. Same way for all those data, it needs to do the circle. Else it exactly knows where to get from, and the data sitting there is very clean. Just go, put your hand into it, pick it up, give it back to the back end. This speed, I am talking only on the lines of an API and the speed with which the API can pick up and deliver. There are other problems or other areas that can impact this. That is how nicely your database is made, how nicely your database is normalized, if people know about normalization, how it is normalized, how fast and the cache of those database server depends on how fast you can get data. And finally, is the architects or the application builders set up something like a caching mechanism. It keeps this data in the cache, which is normally retrieved multiple times over a period of day. The same set of data is needed. So if you put it in cache somewhere, so he knows he doesn't go and jump into a database, pick up from there, you can just pick it up from outside and bring it to you. So it becomes more faster for you. These architectural layouts, architectural designs is what makes or breaks an application. We blame everything on the systems, we blame everything on the network, we blame everything on the front end, the developers. No. There are a lot of things in the back end that really makes or unmakes a system, makes it really usable and worth the effort and money put into that. Or it's just that you purchase another white elephant. For the benefit is you can put in front of a shop saying this, I have a white elephant, but it doesn't do any work for you. It stays there. A branding.
It's not as simple as it looks in the front end. There is a lot of things going on.
There are a lot of things, if properly said, all things go
Yeah.
good. If badly said, your machine starts going down. Like you have a nice car, you drive it properly, you have a good driver who knows how to change the gears, how to run on the road, when to brake. He knows it properly. If he drives it nicely, your life of the car is more. Else you have in the junkyard within 2 years. It was broken down. This is what happens with our systems.
So every click triggers a chain of API calls, right? So in real projects, where do companies actually go wrong?
See, what happens is everything boils down to the architecture on which this was built. While building it, the architecture of the database, the architecture of the APIs and the calls is what makes all the difference. For example, there's one click that happens, and that for that one click, if you have multiple APIs going on to get the result and then combine it, you have more time that's taken and the output comes in a lesser time frame.
Oh, okay.
The more number of APIs for one output will give you lesser data, or maybe when you want more data, the time lag is more.
Okay.
So that's what not breaks but delays the output are quite good. Every microsecond or millisecond that's used is always a delay that comes on the results in the front end. That's one way of doing it. Second is purely structured databases or poorly structured APIs. So you want a small thing, you write a big line of code to get that small thing with a lot of filtration. It becomes slow. The output from the database to the front end is slow. That reduces the speed. Then, as I mentioned again earlier, it's about caching. If you have some set of data that's regularly used by multiple people, it's always better to cache it up somewhere. In the database, last podcast we had discussed about databases. We spoke the difference between Redis as a caching agent and not a database, and we need a database below that. That's the reason we need Redis over that for caching.
Okay.
So this is the reason we need that. So it cannot be used, Redis cannot be used as a database. It's for caching data that's normally used multiple times and not changed every now and then. For example, if your name, your phone number, your address, it doesn't change every millisecond. It lives there for maybe months, at times years. So that is hardly replaced. Those kind of data, if you put in cache, whenever the API calls for that, it's only available, doesn't go and search the database and get it up to you. This speeds up the thing. Then what happens is there's no rate control. We don't control that. This should be a minimum or a maximum amount of this many API calls to the server in maybe a minute or few milliseconds. If we put that restriction there, we don't get a situation where the database or the server crashes due to overload. Whereas if you set a rate restriction, in case of peaks, this result is delayed a bit, but your server is never crashed. Your server hangs on. Once crash and everything goes. But this hangs on, it gives you answers with a bit of delay during peak hours. And when we find that our analytics that there is a regular peak that's coming during this time of the day, we could upgrade the servers during those particular time of the day. For those analytics, we can use that. In these scenarios, we don't have a system that ever breaks. You must have seen at times when you go to the bank ATMs.
Yes.
Sometimes put the ATM card, give a number, the request is fast.
Yes.
Sometimes you find there's a bit delay.
Yeah.
You need to wait maybe 1 second, 1.5 seconds. This is because that's the time when there is more load on the servers and they have put a rate limit there. Else, during those times, you find server crashed and no results, nothing happens. So these are major things. Then it should be not be very tightly coupled systems. When it's tightly coupled, a lot of hard coding in there, what happens is if you want to make a small change, you have to do this change at multiple places. Whereas it's like the old age when the OOPS concept started out, object-oriented programming. So if you have multiple objects, multiple functions, you change one and that function whole runs fine. It's not dependent on multiple things, it's not very coupled up, so you don't need to make those changes everywhere. Wherever this is called, it comes with the new data. So these are the few things, if taken care of during the architecture level, and the tech leaders don't compromise on the cost and time there, then they have better working systems.
Okay, so architecture level is more important than we think.
Now what we see is most of the people on the name of cost cutting, they cut down the architecture, they cut down the drawing board time, they cut down the understanding the current scenario time just to make sure that they reduce on cost. But these are the problems that you face when you cut down those costs. Unless your tech leader is so much into this, he has been working in day in day out for years into the same technology, he has a very clear and clarity onto this what he needs. His drawing boards are well done up, his architecture is done up, then he wants developers, he doesn't need a team to do that. But normally 98% of time it doesn't happen. All these tech leaders are at senior level, they have an eagle's eye view, understanding what they need, how they need to run. But actually what happened behind the scene is done by the team who is implementing it. And that team has to be great. Unless you do that, you are getting the wrong people on board, and finally you are getting a system that works when you are testing it, and when it is implemented real time with almost all the company getting into it, you start getting nightmares, night burnouts, sweat in your foreheads, because things stop working, you don't know why, and you don't know how, and you don't know when. Now it's another exercise, doing the whole thing again to find out what the problem is. The fixing is the second part. It's spending much more money than they could have by doing this in the initial stages. It's always said, building right is the best option rather than rebuilding it. Rebuilding is always costlier wherever it is, in whichever scenario we take. Even if we take on a home front, rebuilding something is always costlier. And not only costlier, it's more of strain, more of a very heavy environment in the organization, nobody trusting you, those things come into play. And more than the actual money or dollar cost, it's the emotional cost that makes a lot of difference. You find your teams, your managers dropping and going you find a lot of attritions just because they get frustrated with these things.
It's like a chain reaction.
It's like a nuclear reaction, nuclear fission we can say. One affects and it starts moving very fast.
So APIs should be designed for the real usage, right? So when the system grows, how much does API affect its scalability?
It makes a lot of difference. See, when the system starts growing, or when your system scales, your company scales, there are three things that scale along with that. There's the number of users, and with each number of users, the number of requests that API sends to the database, and the volume of data that increases. All these three things are scaling together and multiplying much more times than you actually scale the business. Which every user, the number of requests is X times more. The number of data in the volume database is growing pretty fast. 2x, 3x, 4x it goes. So just as fast as you grow, these three things makes a lot of difference. So in this, howsoever good your systems are, that is just the database servers are, if the APIs are not optimized to handle these kind of loads properly, then you have the system slowing down and the front-end users start feeling the drag. What happens in normal scenarios, whenever the front-end users start feeling that it's slow, the first blame comes on the system RAM and the system processor. Okay, that's upgraded. What next? Then it comes on the internet connectivity or the If it is a local LAN, the LAN cabling, the switches. Once that is finished, then it comes to a server. And once that is also done, then you find it's not this, then you start thinking about the database, and you start thinking the database is there, the servers are good, what's the issue? Then it's the communication between these two that's the issue. So all these things are the first things that's looked up, that's upgraded, that's thought of being the culprit, but actually that's not the culprit. It's the architecture of the APIs and the database optimization that needs to be done when you develop an API, develop a database is the most important part. There is a concept of normalization of a database. There are 5 levels of normalization. At least, if not 5, a 3 level of normalization needs to be done. But most of the development teams now we find you need some additional data, create a table, put a few fields, data is there. It doesn't work that way. It can work in a test environment, lab environment. It cannot work in real time. It starts hanging. But most companies don't feel that hang because they have over-engineered the databases, they have over-engineered the Redis for that caching system. So even if more data, more complication, it provides you data. But at one stage, this has to break. When there is a contrast between the server configurations and the API requirements, when it scales, number of users more, number of requests more, it starts hanging. It has to happen. Only thing is you can postpone the death by a few months maybe, depending on this growth graph, whether it's exponential growth or whether it's stable growth. Depending on that, you can just delay the death by a few months, and it has to come.
We can only delay it, not avoid it.
You can't. It has to stop at some stage. You have to re-optimize it. You have to rebuild it.
So APIs can become the bottleneck if not handled well. Where does over-engineering comes to play when the teams try to fix this up?
Yes. What normally happens, the teams start building something, they see problems as anticipation. It's like, for example, you are scaling for around maybe 1,000 users or 10,000 users in the next 1 year. It's a startup, that's what you're looking at.
Yes.
Or a company which is already in engineering, they have now 200 users, they can scale up to 1,000 users or 500 users. That runs for another 3 years. That's a growth pattern normally.
Yeah.
Now what people do is, let's build it. Once you're building it, let's plan for 1 million users or 10 million users.
Okay.
And that's what we call over-engineering. You are not going to get 10 million users in the next 10 years. There's a rate of growth. Howsoever exponential it is, there's a limit of that growth. But 10 million users in 1 year is not possible. So you need 7 to 8 years for that. And you have time, you can rebuild it at that time. No, they start planning, they over-engineer things, they make abstraction level over another abstraction level just to make sure that you can hit 10 million. And you have those kind of servers for that, you have lot of API layers for that. With all this, it becomes so complicated, so complex that a small change that's needed becomes too complicated and takes too much of time and effort to build that, too much of expertise to build that. This is not possible in a smaller environment where the scaling is faster. You need flexibility with things. Changes happen overnight. In such environments, you should not or never plan for something big. And the big planning has to happen as you grow. And things has to, it's not you have to build it something today permanently for next 10 years. It cannot happen in the software industry.
Yes.
It has to change. Technologies, new technologies come, new frameworks come. You have automatically to change. But people have still the mindset, I built something, it should run for next 10 years. It cannot run, they don't understand. Technically, it cannot run whatsoever you built.
Yes.
So this is one problem that most engineering leaders need to understand, that any software application built has to be built with 2 or 3 years in picture. And you always need to plan for another layer of investment at that time. And that's when the next scaling comes, for next 3-4 years. That's how companies should grow. That's how applications should be built. Else Windows, which was built 10 years back, should never be upgraded.
Yes.
They have been upgrading it. Apple has been upgrading the operating systems. Things have to upgrade. And people have to understand that.
So you are saying that trying to be advanced too early can create problems, right?
Yes.
So how can companies approach this API design in a simple way, or maybe in a more practical way?
Exactly. See, API designing or database designing should not be done as a theory. It should be done in a way that uh, it's to be used in a practical sense.
Yeah.
That's the most important
Yes.
part. What you need is what you should build. And it should have clarity. Your every API should have clear endpoints. And it should be used for doing one job and use it only for that job. Don't use it for multiple jobs. That's when the endpoints start becoming unclear, complex. And then what happens, the next state that comes is the data transfer increases. Every API should have minimal data transfer that's needed for doing that job. And that should be very clear. And always by building an API, you should note and take care of the only fact that the responses has to be very fast. Users can detect even 1 millisecond of delay in that. They can feel on the screen. So that should, and there should be a proper documentation of the what the API entails, what is doing, what the endpoints are, what does it give as a result, what is the question that to be asked. There is proper documentation. If a developer who has been to APIs, developing APIs, doesn't understand your API in the next 10 minutes, this is not clear. There is not enough clarity in that API.
Okay.
This is the most important framework that anybody should follow while developing an API. Is it should have clear endpoints, it should have minimal data transfer, it should have fast responses, and the documentation should be awesome. Any developer can understand 10 minutes as a timeline. That's it. If it's not understandable 10 minutes, either the developer is wrong or your API is wrong. You can take a call.
Okay. Okay, that makes it very practical. So now bringing back it to the bigger picture, how API connect to AI and automation systems?
Absolutely. What is AI? AI is a bridge between your front end and the databases. And that's a superhighway with multiple lanes. And the API is a simple bridges. But this AI also needs someone like an API to bring the data it needs from the database
Oh, okay.
in normal sense.
Oh.
But if you make it like a LLM kind of model, the structure name changes. It becomes a vector database. You use some other format for that. But overall, the meaning of something is like it's a pipeline that connects data to all these front ends. One is the front end. Second, the AI layer, which manipulates, understands your natural language, converts that machine language, and converts the data back from machine language to your language, natural language. It processes. So that also needs pipelines and data. Unless you open the tap, the water is not going to come into a glass. Whatever mixture you want, everything happens inside. But the water has to come, and that has to come from database. Whatever sort of database you manage things. So for that is very imperative that the API data is well managed, pretty optimized to the kind of infrastructure or to the kind of frameworks you are building on it, whether it is a API, AI or it is normal front ends. Whatever it is, the data has to be fast, the deliverables has to be fast. It should not be overloaded so that the system starts failing there. The AI asking for more data, they should be able to provide it with the kind of clarity and speed that's needed. So unless you optimize it, it's going to bring in buckets and give it to you. Not formatted, not properly optimized. But if you given optimized and clean data to the AI, it can give you clean and amplified output for you. So if you put it garbage in, garbage is out. Same way, the data that is given in from the database should be cleanly and nicely picked up by the AI and given to the by the API and given to the AIs. Then when you get a proper AI that's working, that gives you the result on the money that you spend on that. Your ROI is only applicable and valuable and valid if you have a proper data structure, if you have a proper bridge or pipelines that connect with the data that's needed, else everything falls apart.
Okay. So all these are interconnected actually.
100. That's all parts of the same engine. Different pieces of the engine connected so that the whole engine starts running. Your car is moving further. Else, if you remove one of the wires from the carburetor, your car stops. It's just a wire or a small pipe, but that stops the vehicle.
Okay, so before we wrap up, if you had to simplify all this into one idea, what should the leaders always remember about API?
They should always not ask the question that what APIs do you need? Do we need? It should be how my systems will be talking to each other and remain interconnected, and the talking will be in a simple, clean language with more clarity and speed. Simple as that. If this is the approach they take, they are successful. If they take an approach that what I have built up everything, now what APIs I need, then this is going to break at some places.
Okay.
Simple as that.
Okay, so I guess they will keep in their mind.
They should. That's what going to help them grow. That's what going to help them in their migrations to newer frameworks. Because newer frameworks are strong, pretty secure. They are high volume capable. But unless if you want to use these performances of the systems or frameworks that you implement, you need proper connectivity designs. That every wire is connected to the other board properly and the wirings are strong so that the data movement between different connectivities and different data frameworks are fast and reliable, and there is no confusion everywhere. What I am supposed to do, every API knows, and it does only that thing and nothing else. That's how. So all future leaders, all tech leaders, and also all future growing founders should also look at this. When you build an application, don't think of building something that you are going to use for next 5 years or 10 years. Build something that you are going to use for next 2 years or 3 years at the max, not more than that. And by that time, you have more clarity and what your customers need and what you need to scale. Now you are just imagining things. Imagination is only your imagination that's coupled with your expertise and the past experiences, good or bad, that you have. And this cannot always be true because the world life scenarios are changing. The technologies are changing, new things are coming up day in and day out. The life of a technologist is becoming very, very easier. And the more easier it becomes, you have more clarity. And that clarity is what is going to help you scale. Not what you build for next 10 years or next 5 years. So always remember, getting the right team who can think on their feet and think on their head, what is it that your company is doing now? What is the kind of data set that you have now? And how are you going to grow? What is the expected growth potential from you? And looking at that, build something for 3 years down the lane with the technology that is stable and available today. Don't use the beta versions. Something that is stable and available today. Build something for 3 years. Optimize every part of that. So when your car is built, if you see, it's in the lab for years or months before the engine comes out. Because every part of the engine is optimized. Even a 2 mm difference in one part of the engine reduces the performance of the engine by maybe 5 to 10%. And just sit back and think, while designing a system, have you done at least 10% of what I'm telling today? Not 80%, not 100%. 10% have you done that? I'm sure it's time you should look at this, go at more than 60, 70, 80% of optimizations and make sure you migrate with that in mind, and you never have a problem with your vacations. You can always take vacations whenever you need because the systems are not going to fall apart and you are not doing any firefighting. You are thinking of the future, you are thinking of scaling, you are thinking of growing, you have time for that. Rather than firefighting and beating the bushfires every day, in and out, no vacations, no Sundays, no Friday night outs, no family time. If you want something that doesn't cost you your life and emotions, get in touch with people like us who have been experienced into this, have a great team behind us. We could help you, guide you, strategize for you how easily and nicely you could build up something that will not kill your emotions, not kill your patience, and will have a great growth with you, along with the family time and vacations that you always look forward to. Have a great time. Share this to somebody else who would be interested in knowing more about how to migrate, how to grow, scale your systems from what you have today and get into the cloud. There are people on cloud already, but think over, have you optimized your systems? Is your systems with the kind of infrastructure you are paying for, are they worth it or are you over engineering? Think over and let's be in touch. We can always have a call and discuss what's the possibilities. Try it out. Have a great time.
Thank you, sir, for a wonderful session. I hope the viewers have gotten a good idea about what API really is. So, we'll be back with another informative session. Until then, bye.